NASA engineers miraculously revived the primary thrusters of the Voyager 1 interstellar probe, which had failed in 2004. The mission team successfully repaired the thrusters of Voyager 1, now approximately 25 billion kilometers from Earth, which had been inactive since 2004. They performed this just before the communication antenna with Voyager 1 and Voyager 2 was set to shut down for several months due to system upgrades. Voyager 1 has been traveling through the cosmos since September 5, 1977. This spacecraft, after completing its primary mission of observing gas giants, has traveled farther than any other spacecraft. Although many of its original instruments are now offline, some simply because they are no longer necessary, like the camera and its last iconic photo, and others due to failures, the thrusters play a crucial role in maintaining the spacecraft's antenna orientation towards Earth. The recently revived thrusters are the primary attitude control thrusters, as the currently active backup thrusters could fail this fall due to clogging in their tubes. In the past, to prevent this buildup, the team occasionally activated all thrusters, but in 2004, the main attitude control thrusters encountered problems when two small internal heaters lost power. At the time, this issue was considered unsolvable. Kareem Bedard, the Voyager mission manager at NASA's Jet Propulsion Laboratory, JPL, stated, at that time, the mission team had come to terms with the failure of the main rotational thrusters because they had a perfectly good backup set. Honestly, they probably didn't expect the Voyagers to last another 20 years, as the communication with the spacecraft will be disrupted from May 4, 2025 to February 2026 for upgrades to the Deep Space Network's Deep Space Station 43 antenna. NASA wanted to ensure all necessary precautions were in place. This 70-meter antenna, located in Canberra, Australia, is part of NASA's Deep Space Network, DSN, and is the most powerful station in the network, being the only one capable of communicating with the now interstellar Voyagers. The upcoming communication blackout prompted the Voyager mission team to investigate the main thruster issue once again. They speculated that an anomaly in a circuit may have altered a switch in the system, and if they could reverse this change with a command, the thrusters might activate again. However, resolving the issue was not without risks. The team had to reactivate the previously inactive thrusters and then attempt to fix the heater problem. If, for any reason, the spacecraft's automated system detected a deviation before the heaters warmed up appropriately and activated the thruster, an explosion could occur. Thus, the team had to carefully calibrate the star tracker that measures the spacecraft's position. Activating the thrusters even on Earth is challenging, especially since it takes over 23 hours for a signal to reach them. Nevertheless, the Voyager team executed the maneuver and succeeded in reactivating the heaters. The main thrusters came back online. Todd Barber, the mission's propulsion system manager at JPL, said, "It was an absolutely magnificent moment. The team's morale was very high that day. These thrusters were considered dead, and that seemed a logical conclusion. But one of our engineers concluded that there might be another issue at play that could be resolved." Once again, a miracle happened for Voyager. This recent achievement showcases the ingenuity and problem-solving abilities of NASA engineers who have kept the Voyager twins operational for nearly 5 decades. These legendary probes continue to send back invaluable data from beyond our solar system, providing a unique opportunity to deepen our understanding of interstellar space knowledge that no other spacecraft has been able to deliver.